Hello and welcome to my shop. Maybe you've seen my other video, I'll link to it, where I build a tactical style aluminum flashlight either out of 6061 or 7075 alloy. This time we're going to try to build a couple of flashlights out of this. This is 6Al4V titanium. It's called 6Al4V because it's 6% aluminum, 4% vanadium, and 90% titanium. That's also known as grade 5, and that is the most popular alloy of titanium. This particular piece is 9 inches long and 1.5 inches in diameter, and on eBay I found it for about $55 to $60. And I bought a couple of these from a couple of different vendors. Here's one that I haven't started to machine yet. And the other one I have started to machine. And I've made a few cuts here. And this is what we're going to talk about in this video. What is it like in the home shop trying to machine titanium? There's certainly a fair amount of drilling that goes on trying to build one of these flashlights. And so when I started my first machining steps here, I tried drilling a bore into it, and pretty quick I found out that normal drill bits just aren't going to cut it. What we see here are a couple of drill bits here. The one on the bottom is a nice fresh cobalt drill bit. The one on the top is one that I used for a little while. And believe me, they get hot pretty quick. Maybe I could have used a little more lubrication, but I don't have anything like flood coolant. And it doesn't take much drilling before you see the smoke rolling off these things. And you can see just how this one didn't get ruined, but it got fairly dark. It's getting pretty toasty. And I did have another one that I did pretty much destroy the top of it on. I had to regrind it and make it usable again. So it seemed pretty clear right away that I was not going to be doing a whole lot of drilling with a simple cobalt drill bit. Another tool that I was using here is a cutoff tool, and I have already reground this, but you can kind of see the darkness on it. I completely destroyed the edge on this, trying to both put a groove in for my O-rings and as a cutoff tool. Now this is a 5% cobalt blade, and it simply did not hold up well to titanium. So I figured I'm going to have to do something different there as well. Alright, so here I have your basic Metalworking Catalog, this one from MSC. And when you open one of these and start looking at cutting tools, you can't help but see all the time for, like, here's an end mill. You can get them uncoated or tin coated or coated with titanium aluminum nitride. It's either that or you see something similar here that's coated with aluminum titanium nitride. Well, those are essentially very close to the same thing. The titanium aluminum nitride has a little more titanium than aluminum, and the aluminum titanium nitride has a little more aluminum than titanium. But they're a similar coating. If we turn a few pages ahead here and I get up around the drill bits, which is one of the things I would like, you can find that you can buy basically a cobalt drill bit coated with titanium aluminum nitride for a lot less money than you would have to spend to buy a carbide drill bit. And what does it have to say about it? You know, for use in high tensile alloys, titanium, cast iron, Inconel, and high nickel stainless steels. The titanium aluminum nitride coated for use where extremely high temperatures are generated in machining stainless steels, nickel-based alloys, and titanium alloys. Well, they're not joking. When you try to machine titanium here, it generates an awful lot of heat. So this coating is supposed to help. So I decided to buy a few things here, and I'll show you what I bought. Okay, to start off with, here's some of the titanium aluminum nitride and cobalt drill bits that I've purchased, all the way from 1/8 of an inch up to 1/2 of an inch. I've used these a little bit so far, and they seem to work wonderfully. Things still get hot, but I can't say that the drill bits have been damaged in any way so far from the drilling. There's actually something about the coating that it likes to see a certain amount of heat, I believe, to work. They actually do say that you're not supposed to use these for aluminum. That might be because you don't generate nearly as much heat with aluminum. So very, very happy so far with the drill bits. Might be nice if they were jobber length instead of screw length, because I could stand a little longer ones, but it's worked out okay. Next thing that I purchased here was some TPG inserts here that are also coated with the titanium aluminum nitride. Here's TPG 222 and 322. Done a little bit of boring so far, turning and facing. They work just fine. Maybe just slightly harder than aluminum, but I mean, no real strain. It goes right through it. Seems to leave a decent surface. All right, and then there's a fair amount of both internal and external threads on the flashlights. So I bought these inserts for my internal threading tool and my external threading tool, same coating. These happen to be full profile threading tools here. That means that when you cut it, it not only cuts the V, but then it lops off the top of the thread, so you really don't have to do much work finishing the thread. It leaves it largely finished. And then lastly, when I get to the end and I do the CNC work, this is a 1/16 inch ball end mill. There's a fair amount of cutting to make the designs using an end mill like this. So this is going to be one of the more interesting things at the very end, to take this and do quite a bit of machining. One of the things they tell you about when you're machining this is you want to start a cut and finish the cut. You don't want to start and stop. Titanium will work harden. So if you get it hot and you just stop in the middle of a cut and go back to start again, you're going to find out the material is much harder than it was when you started. So you want to pick your cut, finish your cut, and not start and stop if you don't have to. Okay, before we proceed any further, let's have a few words about safety. Here's a few chips I've started to generate machining the titanium. And if you do some searches on the internet, you probably, or you already know, maybe if you're machining something like magnesium, extreme care is needed because you get it too hot, it catches fire, you can't put it out, your building burns down. Well, titanium's not quite that bad, but it turns out titanium metal also burns. If you get this hot enough and fine enough, it will ignite. And as they say, it doesn't burn red hot and it doesn't burn blue hot. It burns white hot and extremely difficult to extinguish. I don't think you're going to get chips like this to ever easily catch on fire, but from what I've been reading, if you were to take titanium and, let's say, put it on your grinder and start creating very fine particles of titanium and you get it hot, it could ignite. And people have, of course, have their buildings burned down, and you don't want your shop to burn down. So just a word of caution there, I will be doing absolutely no grinding of any kind on this titanium. And I will also be keeping fire extinguishers at hand, including one halon fire extinguisher I have from the 1980s, which I've never used, which I'm hoping if it ever were needed, I hope I never need it, but if I did need it, it might be the one kind of extinguisher which might actually put out a fire like this. I think the other thing people do with stuff like magnesium and stuff is have a bucket of sand so that you can try to smother a fire. Anyway, word of safety. Alright, let's recap. Here's a finished flashlight here. I made 2 of them. They look equally as nice. There's the switch side. And there's my Celtic pattern. And the strike bezel. And the working end. Okay, so what worked and what didn't work? Well, those titanium aluminum nitride coated tools generally worked well, except for the larger drill bits, which eventually I overheated and destroyed and ended up using just cobalt drill bits and resharpening them very frequently, but made it through it. I think I found uncoated carbide worked pretty well as well. I used several uncoated carbide tools and they were fine. Safety wise, what can I say? You got to be careful. A few more thoughts there. Keeping the chips clear, keeping the oil wiped up, don't get it too hot, keep the tools sharp, watch your speeds and feeds, no grinding. And I think you saw in there in the sandblasting cabinet, I had a little video there of aluminum oxide in the cabinet roughing up the surface so the paint would stick, and that makes quite a light show. That's sort of interesting. And actually it's turned out I think looking better than almost any of the aluminum ones I've made. So I think you can successfully machine titanium in the home shop. I will say in these flashlights I put in the Malkoff Devices M61. These are the 3 ways, low, medium, high, putting out about 400 actual lumens on high, not like those 1,000 or 2,000 lumen internet figures you see all over, which don't mean anything. And I splurged a little bit on the rechargeable battery. They warned you on that LED unit that a set of CR123As was only going to go 15 minutes on high, so they recommend using an 18650, and so make sure it's rechargeable so you're not buying batteries all the time. And at any rate, thanks for watching.